In physics, a state of matter is one of the distinct forms in which matter can exist. 4 states of matter are observable in everyday life: solid, liquid, gas, and plasma. 5th state is Bose-Einstein condensate. Many intermediate states are known to exist, such as liquid crystal, and some states only exist under extreme conditions, such as Bose-Einstein condensates, neutron-degenerate matter, and quark, gluon plasma, which only occur, respectively, in situations of extreme cold, extreme density, and extremely high energy. The term phase is sometimes used as a synonym for state of matter, but a system can contain several immiscible phases of the same state of matter. Solid: in a solid, constituent particles, ions, atoms, or molecules, are closely packed together. The forces between particles are so strong that the particles cannot move freely but can only vibrate. As a result, a solid has a stable, definite shape, and a definite volume. Solids can only change their shape by an outside force, as when broken or cut. In crystalline solids, the particles, atoms, molecules, or ions, are packed in a regularly ordered, repeating pattern. There are various different crystal structures, and the same substance can have more than one structure, or solid phase. For example, iron has a body-centered cubic structure at temperatures below 912 degrees Celsius, 1674 degrees Fahrenheit, and a face-centered cubic structure between 912 and 1394 degrees Celsius, 2541 degrees Fahrenheit. Ice has 15 known crystal structures, or 15 solid phases, which exist at various temperatures and pressures. Glasses and other non-crystalline, amorphous solids without long-range order are not thermal equilibrium ground states. Solids can be transformed into liquids by melting, and liquids can be transformed into solids by freezing. Solids can also change directly into gases through the process of sublimation, and gases can likewise change directly into solids through deposition. Liquid: a liquid is a nearly incompressible fluid that conforms to the shape of its container but retains a, nearly, constant volume independent of pressure. The volume is definite if the temperature and pressure are constant. When a solid is heated above its melting point, it becomes liquid, given that the pressure is higher than the triple point of the substance. Intermolecular, or interatomic or interionic, forces are still important, but the molecules have enough energy to move relative to each other and the structure is mobile. This means that the shape of a liquid is not definite but is determined by its container. The volume is usually greater than that of the corresponding solid, the best known exception being water, H2O. The highest temperature at which a given liquid can exist is its critical temperature. Gas: a gas is a compressible fluid. Not only will a gas conform to the shape of its container but it will also expand to fill the container. In a gas, the molecules have enough kinetic energy so that the effect of intermolecular forces is small, or zero for an ideal gas, and the typical distance between neighboring molecules is much greater than the molecular size. A gas has no definite shape or volume, but occupies the entire container in which it is confined. A liquid may be converted to a gas by heating at constant pressure to the boiling point, or else by reducing the pressure at constant temperature. At temperatures below its critical temperature, a gas is also called a vapor, and can be liquefied by compression alone without cooling. Plasma: like a gas, plasma does not have definite shape or volume. Unlike gases, plasmas are electrically conductive, produce magnetic fields and electric currents, and respond strongly to electromagnetic forces. Positively charged nuclei swim in a sea of freely moving dissociated electrons, similar to the way such charges exist in conductive metal, where this electron sea allows matter in the plasma state to conduct electricity. A gas is usually converted to a plasma in one of two ways, e.g., either from a huge voltage difference between 2 points, or by exposing it to extremely high temperatures. Heating matter to high temperatures causes electrons to leave the atoms, resulting in the presence of free electrons. This creates a so-called partially ionized plasma. At very high temperatures, such as those present in stars, it is assumed that essentially all electrons are free, and that a very high-energy plasma is essentially bare nuclei swimming in a sea of electrons. This forms the so-called fully ionized plasma. The plasma state is often misunderstood, and although not freely existing under normal conditions on Earth, it is quite commonly generated by either lightning, electric sparks, fluorescent lights, neon lights, or in plasma televisions. The sun's corona, some types of flame, and stars are all examples of illuminated matter in the plasma state. Bose, this state was first predicted, generally, in 1924-1925 by Albert Einstein following a paper written by Satyendranath Bose. A Bose-Einstein condensate, Beck, is a state of matter, also called the fifth state of matter, which is typically formed when a gas of bosons at low densities is cooled to temperatures very close to absolute zero, -273.15 degrees Celsius. Under such conditions, a large fraction of bosons occupy the lowest quantum state, at which point microscopic quantum phenomena, particularly wave function interference, become apparent macroscopically. A Beck is formed by cooling a gas of extremely low density, about 100,000th, 1/100,000, the density of normal air, to ultra-low temperatures. Hope we didn't disappoint you. Hope we will come with such more stuff soon. Enjoy your day, science lovers.